This video, I will explain how you can determine what mechanism will prevail whenever a nucleophile or a base reacts with an alkyl halide. There is always competition going on between SN1, SN2, E1, and E2 mechanisms. But there are two variables that could help you decide which mechanism will prevail. These variables are the structure of the alkyl halide, which could be methyl, primary, secondary, or tertiary, and the nucleophile or a base. Most reagents could act as a nucleophile or as a base. You would need to categorize your nucleophile or a base as either strong-strong, strong-weak, weak-strong, or weak-weak. Let's take a look at some of these classifications of reagents. So for the weak-weak category, these are neutral molecules with oxygen that is bonded to a proton. So these are weak nucleophiles because the oxygen in them, being a strong electronegative atom, doesn't readily donate its lone pairs. As a base, they are considered weak also because they are stable molecules. So when molecules are stable, they are considered weak bases. And when molecules are unstable, they are considered strong bases. So this category of reagent will give always a mixture of SN1 and E1 product. For the next category, these are the bulky bases. So the bulky bases will always give you E2 product only. The next one is the strong weak category. For the strong weak category, this will always give you SN2 only. And the reason is that for this group of molecules, they are neutral molecules that have lone pairs on less electronegative atoms. So that means they can readily donate their lone pairs, making them strong nucleophiles. And these are weak bases because they're pretty stable molecules. And for this other category of reagents, so these ones are considered strong nucleophiles because they have negative charges, which indicate excess electrons. So they have excess electrons to donate. Now, as bases, they're pretty stable. Though they have negative charges, the negative charges could be stabilized either by size or polarizability and resonance. So these ones will always give you SN2 product. Now, for this other category, the strong, these are strong nucleophiles as well as strong bases. Strong nucleophiles because they have negative charges, which shows that they have excess electron density, and strong bases because they're pretty unstable molecules. So for this category, we will need to explore the alkyl halide structure in order to decide what mechanism will prevail, whether it's going to be SN2 or E2. If we have a methyl halide, which mechanism will prevail? Is it going to be SN2 or E2 if the reagent is a strong reagent? Now in SN2 mechanism, we know that the nucleophile will attack the alpha carbon. So in methyl halide, there is enough space because hydrogens are pretty small atoms. So because there is enough space, the nucleophile can easily attack the alpha carbon and kick out the leaving group. So SN2 will prevail. On the other hand, for E2 to happen, a base needs to grab the beta proton. And in this case, there is no beta carbon and no beta proton. So SN2 will prevail. Now, when you have a primary alkyl halide, there is one bulky group, and then we have two small hydrogen atoms. So the nucleophile can still easily access and attack the alpha carbon and kick out the leaving group. So in this case, SN2 will prevail over E2. For E2 to happen, a base needs to grab one of the beta protons, but SN2 have higher chances of occurring because of the large space that we have here. In the case of secondary alkyl halides, we have bigger groups. So the space here has reduced for the nucleophile to attack the alpha carbon. So SN2 chances will become very low here. However, in the case of E2, we have 2 beta carbons. And what this means is that there are 6 beta protons that could be abstracted by the base. So there is higher chances of E2 mechanism occurring here. Actually, E2 will prevail in a competition between SN2 and E2 when you have a secondary alkyl halide, and when the reagent is a strong reagent, E2 will prevail. Now for tertiary alkyl halides, these are bigger groups. So there is no space for a nucleophile to attack the alpha carbon. SN2 will not occur here. In terms of elimination reaction, so we have 3 beta carbons and 9 beta protons. So there is higher chances of E2 occurring, and actually E2 would predominate in this case. Let's explore some examples. In this example, the question asks us to determine the prevailing mechanism and then predict the product of the reaction below. To solve this problem, you need to first identify what type of alkyl halide do we have here. So here we have a tertiary alkyl halide because there are 3 carbons that are attached to the alpha carbon. We also need to look at what type of reagent do we have. Our reagent here is strong. So based on the tertiary alkyl halide, we know tertiary alkyl halide could do SN1, they could do E1, and they could do E2, but not SN2. But based on strong, as a strong nucleophile, SN1 is not possible. And as a strong base, E2 will prevail. So the prevailing mechanism here is going to be E2. Now, in an E2 mechanism, essentially what happens is that the strong nucleophile attacks the alpha carbon from the opposite side as a leaving group and then kicks out the leaving group, such that a final product then will be this. And we'll also have side products. Let's look at the next example. Here we're asked to determine which mechanism will prevail and also to determine the product of the reaction. So we know that our reagent here is a weak reagent, and our alkyl halide is a secondary alkyl halide. Secondary because 2 carbons are attached to the alpha carbon. So based on secondary alkyl halide, we know SN1, SN2, E1, and E2 is possible. But based on the weak reagent, the weak always favor SN1 and E1. So this tells me that I'm going to have SN1 product as well as E1 product. So the SN1 product will be such that I will replace the leaving group with the nucleophile. And for my E1 product, I will have to place a double bond between the alpha and the beta carbon. So these will be the 2 products I will have. In this example, we know that our reagent is a strong weak reagent, but our alkyl halide is secondary. So since we have a secondary alkyl halide, and we know that strong weak reagents always favor SN2. So SN2 will be the prevailing mechanism in this case. And the product will be such that the nucleophile will replace the leaving group, but there's going to be an inversion of stereochemistry since it's an SN2 mechanism. In this example, our reagent is a strong reagent, and the alkyl halide is primary alkyl halide. So the primary alkyl halide can only do SN2 and E2. It cannot do SN1 and E1. Now, based on the reagent, we have a strong nucleophile and we have a strong base and primary alkyl halide. So this will favor SN2. Therefore, the operative mechanism here is going to be SN2. And so our product is going to be an SN2 product. And all we have to do is to replace the leaving group with the nucleophile. And this is where I will end the video.